Hello students, let us read this question. Find the inverse of the matrix if it exists. So we have been given one matrix and we need to calculate the inverse for the matrix. So we know that inverse of a matrix A is given by 1 upon determinant of A into adjoint of A. Now in order to check whether inverse of a matrix exists or not, we need to find out the determinant of that matrix. If the matrix determinant comes out to be not equal to 0, we can say that inverse exists. So let us first calculate, or let us first consider this given matrix equal to A, matrix A sin alpha and minus of cos alpha. So first we will calculate determinant to check whether the inverse exists or not. So this will be 1 into cos minus of cos square alpha minus of sine square alpha plus 0 into this will be 0 into 0, so this is 0, then this is minus and plus 0 times this will be 0 into 0, so again it is 0. So therefore determinant comes out to be minus of cos square alpha plus sine square alpha. Now cos square alpha plus sine square alpha is 1 by trigonometry identity. So therefore the determinant comes out to be minus 1. Now since it is not equal to 0, we can say that inverse for the given matrix exists. So we will calculate the inverse now. So in order to calculate the inverse, we need to calculate the adjoint of A. And we will for adjoint of A, we will calculate the cofactor matrix. And by taking the transpose of cofactor matrix, we will calculate the adjoint. We will get the adjoint of A. So for cofactor matrix, first let us write down the matrix here. So 1 0 0 0 0 cos alpha sin alpha sin alpha minus cos alpha. So for a cofactor matrix, first we will calculate the minor. So in order to calculate the minor, we need to hide the corresponding rows and columns and calculate the determinant of the remaining elements. So for M11, we will hide first row and first column. So what we get is cos alpha sin alpha minus cos alpha. So this will be minus of cos square alpha plus sin square alpha, which is minus 1. Then M12 will be, so this is first row, second column. So it will be 0 sin alpha 0 sin alpha 0 minus cos alpha. It will be 0. Then M13 will be first row, third column. So it is 0 cos alpha 0 sin alpha. It is 0. Then M21 will be second row, first column, 0 0 sin. So it will be M21 means second row, first column. So this is 0 0 sin alpha and minus cos alpha. So it is again 0. Then M22 will be second row, second column. So that means it will be 1 0 0 cos alpha. 0 minus of cos alpha. So this is minus cos alpha. Then M23 will be 1 0 0 sin alpha. 1 0 0 sin alpha. So it is sin alpha. Then M31 is third row, first column, 0 0 cos alpha sin alpha. 。 it is 0, then M32 is third row, second column, so 1 0 0 sine alpha, 1 0 0 sine alpha, it is again sine alpha, and M33 will be 1 0 0 cos alpha, 1 0 0 cos alpha, so it is cos alpha. Now we can calculate the elements of the cofactor matrix. So it is A11, which is given by -1 raised to 1 plus 1 M11. So M11 is -1. So 1 into -1 will be -1. Then A12 will be -1 raised to 1 plus 2 M12. M12 is 0. So this will be 0. M13 will be -1 raised to 1 plus 3 M13. M13 is 0, so this will be 0. A21 will be -1 raised to 2 plus 1 M21. M21 is again 0, so this will be 0. A23 will be -1 raised to 2 plus 3 M23. Now M23 is sine alpha. Sorry, this will be, first we need to calculate A22. So this will be A22 is -1 raised to -1 raised to 2 plus 2 into M22. So M22 is minus cos alpha. So this is minus of cos alpha. Then A23 will be -1 raised to 2 plus 3 M23. Now M23 is sine alpha, and minus of that will be minus of sine alpha. Now A31 is minus raised to 3 plus 1 M31. M31 is 0, so this will be 0. A32 is -1 raised to 3 plus 2 M32. M32 is sine alpha, minus of that is minus sine alpha. A33 will be -1 raised to 3 plus 3 M33. Now M33 is cos alpha, 1 into cos alpha is cos alpha. So we have calculated the elements of the cofactor matrix. So our cofactor matrix comes out to be -1 0 0, then 0 minus cos alpha minus sine alpha, then 0 minus sine alpha and cos alpha. So this is our cofactor matrix. From this, if we take the transpose, that means if we replace the rows with column and columns with rows, we will get the adjoint. So this will be -1 0 0, then 0 cos alpha, 0 minus cos alpha minus sine alpha, and 0 minus sine alpha cos alpha. So this is our adjoint of A. So this is our adjoint of A. So now we can calculate the inverse using the formula 1 upon determinant of A into adjoint of A. So therefore inverse comes out to be determinant is equal to -1. So this is -1 into adjoint of A is -1 0 0 0 -1, then it is 0 0, then 0 minus cos alpha minus sin alpha, 0 minus sin alpha, now if we multiply this 1 inside, so inverse becomes 1 0 0 0 0 cos alpha sin alpha minus of cos alpha. So this is our inverse of the given matrix. So we have calculated the inverse for the given matrix. So I hope you have understood it well, and thank you.
Don't forget to like and subscribe.